On this hot afternoon, remote sensing scientist Deepak Mishra and his team are at the University of Georgia campus transit bus yard, installing a temperature sensor on the front of a bus.
We are able to do this research because of the revolution in sensing technologies, the explosion in data science research.
At the peak of summer, about 30 buses will be similarly wired up.
We're collecting temperature data from these buses every 5 seconds as they go around the campus, go around the town.
Volunteers, mostly students, are pitching in too, with wearable sensors strapped to their backpacks and belts.
And then we start seeing how these temperatures are changing across town, which areas are consistently showing high temperatures, and what happens in the evening time, what happens in the night time.
32 is about 90 Fahrenheit.
With support from the National Science Foundation, the University of Georgia team is compiling highly detailed, fine-resolution maps showing what's called the urban heat island in their town of Athens, Georgia.
Heat is the leading weather killer. It kills more people every year than tornadoes, hurricanes, floods.
Scientists have known about the urban heat island effect for decades, making maps from satellite data. Heat islands are urban areas that are hotter than their less developed surroundings, mostly because they're largely devoid of trees. Dark surfaces like roads and rooftops absorb heat and radiate it back out. Some parts of a city can be as much as 15 degrees hotter than others.
This project is going beyond that to see what is happening within the urban heat island.
Usually when you check the weather, you get one temperature reading for a whole city. But what if you could know the temperature on a block-by-block, street-by-street basis?
So we're trying to figure out how this temperature changes at a very fine scale so that people can better prepare.
Geographer Andrew Grunstein studies how weather and climate affect human health. He says hyperlocal heat maps could save lives by pinpointing pockets of extreme heat.
Heat stroke is the most serious heat thing. Your organs can shut down. It can be life-threatening. So we really want to prevent people from getting to that point.
Particularly at risk are the elderly, children, athletes, people with chronic medical conditions like diabetes, and those who do physical labor outside.
People that, say, can't afford air conditioning or don't have air conditioning can be at risk. Some research shows that poorer communities are often in hotter parts of cities because they don't have as much green space.
Computer scientist Lakshmish Ramaswamy is the lead on the data gathering and analysis. They've designed a smartphone app to make the wearable sensors easy to use. They need clean data to make the maps reflect real on-the-ground conditions.
Okay, this particular sensor, somebody carried it, maybe they put it in their pocket or maybe they put it in their backpack. So the data that is coming out is anomalous. Can we detect that using data mining algorithms, machine learning algorithms?
Only then can they use the data set to make fine-tuned inferences and predictions about temperature variations over short distances within a city.
Long term, can we predict what is the exposure profile of a particular individual or a particular community? For example, the community of city workers who are doing the road work or the garbage collectors out there. What kind of heat exposures are they facing?
This project in Athens is a small-scale experiment, but Mishra expects these heat maps will be commonplace in the future. City planners will use them to decide where to plant trees. Communities can use them to make sure people at risk have access to water and air-conditioned spaces.
I see a day when people have this app in their phone and then the phone tells them, take this route, you'll be less exposed to urban heat.
Using data to drive better decision-making when the heat is on. For Science Nation, I'm Miles O'Brien.